Hi friends, I am going to explain about the two more questions from definite integrations. Okay, here I am taking one question. Find the area of the region bounded by y equals to x cube plus 3 and x axis where x equals to minus 1 and x equals to 2. Okay, given curve is y equals to x cube plus 3. Therefore, required area is integral 2 to minus 1. Here x is 2 to minus 1. The function is x cube plus 3 dx. Now we have to do integration of x cube plus 3. Integration of x cube is, we can write down x power of 4 by 4 plus, for integration of 3 is 3x. So this is from 2 to minus 1. Now we have to substitute both 2 and minus 1 in this equation. So if we substitute 2 power of 4 by 4 plus 3 into 2 minus of minus 1, we have to substitute in place of x, minus 1 power of 4 by 4 plus 3 into minus 1. 2 power of 4 is a 16 by 4 plus 3 2 is a 6 minus 1 power of 4 is a 1 by 4, 3 1 is a 3, and it is a plus into minus, minus 3. 4 ones, 4 fours, 4 plus 6 is a 10 minus 1 4 3 is a 12, that is minus 12 plus 1, that is minus 11 by 4, minus into minus plus 10 plus 11 by 4, 4 tens 40, 40 plus 11 51 by 4 unit square. And we can take this curve as here minus 1, here 2. This function is from 2 to minus 1, so that we can take like here. Find the area of the bounded by the parabola y equals to x square, x axis, x is from minus 1 and 2. Now given curve is y equals to x square, then required area is area integration from 2 to minus 1 x square dx. Its integration is x cube by 3 from 2 to minus 1. That implies we have to substitute 2 and 1. 2 cube by 3 minus 1 cube by 3. 2 cube is 8 by 3 minus 1 cube is a minus 1 only by 3. 8 by 3 minus into minus plus 1 by 3, that is 8 plus 1 by 3, finally 3 unit square. Its curve also minus 1 to 2. Evaluate integration from 1 to 0 x square by x square plus 1 into dx. Integration 1 to 0. Now this I am writing x square plus 1 minus 1 plus 1 minus 1 is we can get to 0 only. Finally we can get x square by x square plus 1 dx 1 to 0, and this is I am writing x square plus 1 by x square plus 1 minus 1 by x square plus 1 dx. Integration from 1 to 0. I am writing now individual x square plus 1 by x square plus 1 dx minus from 1 to 0 1 by x square plus 1 dx. Here both are same, we can get cancel. 1 to 0 1 into dx. Now from 1 to 0 it is like 1 plus x square dx. Integration 1 is x, this is from 1 to 0, minus 1 by 1 plus x square. Integration of 1 by 1 plus x square is a tan inverse x, so which is also from 1 to 0. So now we have to substitute 1 and 0. First 1, and for this one 0 minus of, and we can substitute here 1 to 0 in place of x. Tan inverse of 1 minus tan inverse of 0. Okay, now we can get here 1 minus tan inverse 1, nothing but in tan table at 45 degrees we can get 1, so that it is equals to 45, that is pi by 4, minus tan 0 we can get at 0 degrees, so that 0 degrees. So finally 1 minus pi by 4, integration pi to 0. From this 2 I am taking common, 1 plus, when you take 2 common here 1 plus cos theta we can get into d theta. Integration pi to 0 root over 2 into, it can be written 1 plus cos theta can be written as 2 cos square theta by 2 d theta. And it is a 4, when you take 4 outside of the root that become 2. Finally inside of root is a cos square theta by 2 is there into d theta. The square and root gets cancelled, and I'm taking 2 is outside of the integration because that is a constant 0, and here is left cos theta by 2 d theta. Integration of cos theta by 2 is a sin theta by 2 by theta by 2 derivation is 1 by 2, and this is from pi to 0. 2 into, and 1 by 2 when you take reciprocal it becomes 2, only in the bracket sin theta by 2 is there. This is from pi to 0. 2 to the 4. Now we have to substitute this both pi and 0 in the sign in place of theta. Sin pi by 2 minus sin 0 by 2. 4 into Sin pi by 2. Sin pi by 2 is nothing but 90 degrees. At 90 degrees sin is a 1 minus sin 0 by 2. 0 by 2 is a 0 only. Nothing but sin 0 is a 0. Now integration of 2 to 0 root over this 4 I am writing 2 square minus x square dx. It is like integration of a square minus x square into dx, that equals to x by 2 of root over a square minus x square plus a square by 2 of sin inverse x by a. Let's see. So from this formula we have to apply here. A equals to 2 and x equals to x only. Writing here this value equals to, we can write x by 2 of root over 2 square minus x square plus a equals to here, a square is nothing but a 2 square, 2 square by 2 sin inverse. Here x is nothing but x only, but a equals to here 2 is there. This is from 2 to 0. Now we have to substitute 2 and 0 in place of x. First time I have to substitute 2 by 2 root over 2 square minus 2 square plus 2 square by 2 sin inverse 2 by 2 minus of, now we have to substitute 0 in place of x. 0 by 2 root over 2 square minus 0 square plus 2 square by 2 sin inverse 0 by 2. I substituted 2 and 0 in place of x. Here 2 gets cancelled, that is 1 into root over 2 square minus 2 square is a 0 plus here 2 square is nothing but 4 by 2 is a 2 only, sin inverse 2 by 2 by 2 is a nothing but 1 minus it is a 0 into something 4 minus 0 plus, and we can get here 2 square is a 4 by 2 is a 2 only, sin inverse 0, and is 1 into something 1 into 0, root to 0 is a 0 into something 0 only, plus 2 into sin inverse 1. Sin inverse 1 is nothing but, in sin table 1 we get at 90 degrees, so that 90 degrees I am taking here, minus it is a 0 into something 0 plus 2 into, in sin table 0 at 0 degrees we can get, and so 0 we can get here. Here 2 gets cancelled, pi, and here 2 into something 2 into 0 only, so find 0. So finally answer is pi. Okay, thank you friends, thank you for watching my video. If you like this video, please subscribe my channel and share to your friends.